Hello everyone. In today's class, we will see very important topic, that is Young's double slit experiment. This is very important. So this is an English scientist, that is Thomas Young, and he in 1802 he demonstrated the interference of light. What he did, he has taken two identical slits, S1 and S2, which are parallel and very close to each other. You can see here. These are the two slits which are parallel to one another. And these slits are illuminated by another narrow slit, yes, which is in turn illuminated by a bright source. Means whatever the light source is there, it is here, and he has made one slit here. Now this S1 and S2 will behave as a coherent sources, and this P is there. This is what the screen is. Okay. So number of alternate bright and dark fringes will observe on the screen, right? These bands are called interference bands. Okay, can you see here? There is one dark band, then bright band, then again dark band. So alternate dark and bright bands we are getting. So when we are getting bright bands, when there is a constructive interference. What is there? Constructive interference. And dark bands when destructive interference. Destructive interference already I told. Destructive interference means what? When crest of one wave overlap with trough of another wave. And constructive means what? When crest of one wave overlap with crest of another wave. So to find the positions of the dark and bright fringes, let us find the path difference. Now we are going to find the path difference. Now, see here. So see, this is a source. This is slit S. These are the two slits S1 and S2, which are separated by distance small d. And this is a screen, and this is the distance between these two slits and the screen is d. Now I am selecting one point P where these waves are going to reach from these different slits, right? So light from a slit is made to fall on two slits S1 and S2 separated by distance d, already I told. So two rays, now S1P and S2P interfere each other where at point P. Then let us suppose path difference is what? X. X is the path difference. X is the path difference means suppose this is the first wave, it is going like this, and this is another wave, it is going like this. If we will take this subtraction, you will get path difference. That is just 2P minus S1P. Now see here. In a triangle S1DP, which triangle I am taking? This triangle above one. So see here, in triangle S1DP. Okay. Here this is a hypotenuse. So can I write like this? S1P whole square is equal to S1D whole square plus PD square. This square plus this square. Okay. Now S1P is what? S1P we don't know. So let's find out that only. Okay. S1D do you know? Yes, S1D is what? Capital D. So I am substituting here capital D square. PD square. PD we know, we don't know. But PO we know. But PD is what? PO minus DO. So can I write Y minus D by 2? Yes. So here it is Y minus D by 2 whole square. Call this equation number 1. Which is what your S1P whole square. Okay, understood. Next. Now similarly, from triangle, I am taking S2EP. From triangle S2EP. Again you see S2EP triangle में S2P whole square is equal to S2E square plus PE whole square. Okay, so S2E is what here again? S2E is again D. So here it is capital D square plus. Now this distance is y plus this d by 2. So therefore what you are getting here? Y plus d by 2 whole square. This is what you are S2P square. Call this as equation number 2. Okay, understood? Right? Now let's move ahead. Okay, so we got these two equations, that is S1P square is equal to d square plus y minus d by 2 whole square, and S2P is equal to d square plus y plus d by 2 whole square. Okay, now let's move ahead. Now from equation 1 and 2, or subtracting equation 2 from 1, we are doing subtracting equation 1 from 2. So that is nothing but what? S2P square minus S1P square. Okay, what is S2P square? This one, d square plus y plus d by 2 whole square. Substitute करेंगे. So this is yours d square plus y plus d by 2 whole square minus, this is a d square plus y minus d by 2 whole square. We have to subtract this. Okay, so let's subtract now. So first I am expanding this from the formula a plus b by 2, a plus b whole square. So this is y square plus 2 into y into d by 2 plus d square by 4. This is minus into bracket d square plus, this one is again I am taking small bracket, y square minus 2 into y into d by 2, yes or not, plus d square by 4. Okay, now this is going to be d square plus y square plus this 2 and 2 will get cancelled here. This is just yd plus d square by 4 minus capital D square, and this is again with this minus, this is minus y square, then this minus minus is going to be plus, again here 2 is going to cancel, so this is again here plus yd because I am multiplying with this minus, and again here it is minus d square by 4. Okay, right. Now let's cancel. This d square will get cancelled with this d square, then this y square will get cancelled with this y square, and this d square by 4 will get cancelled with this d square. What is left here now? This is yd plus yd, which is equal to 2yd. Okay, now this side is what? This is nothing but what? S2p square minus S1p square. Okay, now we know a square minus b square formula, a plus b, a minus b. So can I write like this? S2p plus S1p, another bracket, S2p minus S1p, which is equal to 2yd. Yes. Now Already we have mentioned here that path difference S2P minus S1P is what? X. You can see here. Can you see here? Listen, already path difference we have mentioned as X. X is equal to S2P minus S1P. So I will substitute at the place of this, I will substitute X. So I am getting here X, and this is S2P plus S1P into X, which is equal to 2Y and D. Okay. Now, if suppose these 2 points or point P is very near, we can say if point P is very near, very near to O, because here you see this is center point, we can say. So if it is very near to O, it means what? S2P is going to be nearly equal to S1P, and which is exactly what? Straight line. So this is your D, and therefore if I will substitute here, then this is going to be dx is equal to 2yd. But here you see S1P plus S2P is there now, so there how much you are getting? D plus D. Okay, so that's why I'm writing D plus D into X, because there it is S2P plus S1P. Okay, shall I write again? One step I will add so that you'll understand. You can see here now S2P and S1P is equal to D, nearly equal to D. So here what we are having, so therefore I am writing this step S2P plus S1P into X is equal to 2YD, and this is D, so this is your D into this plus, again I am writing this also D, bracket close, is equal to 2YD, and therefore what we are getting, 2DX is equal to 2YD, and now I am cancelling this 2 and 2 from both sides, and I want path difference, then my formula is going to be what? And therefore X is equal to YD by capital D. What is that? X is equal to YD by capital D. This you keep it in mind. This is very important formula for path difference. That is X is equal to YD by D, where Y is what? Distance of point P from the center, that is central bright band, we can say. Okay, D is the distance between screen and the slit, and small d is what? Separation between the slits. Understand? Okay. Right. Now, when point P will be bright spot and when it will be dark spot, that is also conditions we have to learn. So see here now, maxima. Maxima means what? Bright bands. You know? What is that? Bright bands. Maxima means what? Bright bands. Or point P will be bright, fair. So I'm writing only bright band instead of bands. So when it will be, or bright spot also you can say. So see here, point P will be a bright spot point P will be a bright spot. If the path difference x, if the path difference x is an even multiple of lambda by 2. That is, if lambda d by d is equal to 2n lambda by 2, and then you are getting, sorry, here y, no, 1 minute, here it is y, yd by d, है ना, yd by d is equal to this one. This is yd by d is equal to n lambda by 2, and therefore if this 2 and this 2 is getting cancelled, what we are getting, y is equal to n lambda capital D by small d, where n is equal to 0, 1, 2 and 3 and so on. Okay, for this you will get bright spot. Okay sir, but if I want to find distance from the center bright band, that is from point O, then how I will find? So let's see now. Here, if n is equal to 0, I am keeping y is equal to 0. Then if n is equal to 1, then first bright spot at lambda d by d. If n is equal to 2, then 2 lambda d by d. This is small d, na? Yes, kinda small d. Change karo. Here both places I wrote d. You just make it here small d. Okay, because this d is going down. So this is small d. Right? So see, where n is equal to 0, if n is equal to 0, that is what? Y is 0, that is the first bright spot. Then second, third, and all. Okay. So that is center. First one is first, second one is second, and so on. So see here. So thus bright bands are obtained at distance. Thus bright bands are obtained at distance zero, comma lambda d by d, है ना? N is equal to 0. Then n is equal to 1. Next, n is equal to 2. Then what you are getting? 2 lambda d by small d. Then 3 lambda d by small d, and so on. From the center O of the screen. From the center O of the screen. है ना? Can you see the diagram? Here it is. From this point, from center O to the whatever the bright spot or dark spot you are getting, that is what we can calculate. Okay, this is what about bright band or bright spot we can see. What about dark spot, that is minima? So see here, next is for minima. Minima in bracket dark band or dark spot, whatever you want you can say. Dark band. Now when we will get this dark spot, if path difference is odd multiple, है ना? Path difference is odd multiple. So see here, point P will be a dark spot if the path difference x, if the path difference x is an odd multiple of lambda by 2. That is, if yd by capital D is equal to 2n plus 1 lambda by 2. That is, or y is equal to, what you will get, 2n plus 1 lambda into this capital D divided by small d, where n is equal to what? Again 0, 1, 2, 3 and so on, right? So this is what? Dark band. So if n is equal to 0, substitute karo, what you will get? Lambda d by d. So therefore we are getting dark fringes sphere where, or dark band sphere where, at lambda d by d. Then next 3 lambda d by d. Yes. One more 2 is missing my here. This 2 you should write. Okay. So lambda d by 2d. This 2 is already there. So now let's see. Thus dark bands are obtained. Thus you can keep this formula also in a box. Yes. Okay. So thus dark bands are obtained at where put now n is equal to 0. This will become 0. So what you are getting? Lambda d by 2d, first dark band. Next where you are getting, put here 1, 2 into 1, 2, 2 plus 1, 3, 3 lambda d by 2d, है ना? 3 lambda d by 2d. Next 5 lambda d by 2d and so on. From the center O, from the center O. Yes. Now see, from the position of the dark and bright bands, from the positions of or just simply we can note down like this, alternate dark and bright fringes will be formed, you know, alternate dark and bright fringes will be formed. Alternate dark and bright fringes will be formed. Yes, this is what your note point we can say. Right. Yes. Even I showed in the diagram also, you can see. Here you see. Here dark band, bright band, dark band, bright band, dark band, bright band, like that. Okay. You are getting alternate bright and dark spots. Okay. Okay. Let's move ahead. Note down this all. Next one. Fringe width or band width. What is that? Fringe width or band width? Fringe width or band width? And it is denoted by beta. Okay, it is denoted by beta. Keep it in mind. It is denoted by beta. Fringe width or band width. What is this fringe width? Can I write like this? It is the distance between, or it is the distance between two consecutive bright or dark fringes. Yes or not? I will show the diagram. See here. You see. Distance between these two, if I will find out, I will get this fringe width, either bright or dark. Fringe width will be same for both the spots. You know? So I am writing like this. See here, can I write like this? That it is the distance between two consecutive it is the distance between two consecutive bright or dark fringes. Bright or dark fringes. Is the distance between two consecutive bright or dark fringes. Now let's find out this formula for this. Now see here. Let xn let xn and xn minus 1 be the distances of nth and n minus 1th bright fringes respectively. Bright fringes respectively from center O. From center O. Now, then what we will get beta? Beta is equal to xn minus xn minus 1, which is equal to n lambda d by d minus n minus 1 lambda d by small d. Okay. So now let's see what you are getting here. N lambda d by small d minus this is n lambda d by small d minus minus plus. So this is you are getting lambda d by small d, isn't it right? Now just cancel these two terms. What we are getting, this and this term is getting cancelled, and you are getting beta is equal to, therefore beta is equal to lambda d by small d. Okay, beta is equal to what? Lambda d by small d. Even if you will use that dark fringes formula also, you will get same answer. That's why I'm writing here one note point. Note point is what? Distance between two consecutive dark fringes is also equal to lambda d by d. Hence the bright and dark fringes are equally spaced, है ना? Hence dark and bright fringes are equally spaced. Okay, so note down these notes carefully. It is very important topic, Young's double slit experiment. Right, I am sending you one assignment immediately after the class. You can start solving. Okay, so let's stop here for today. Bye.